Hi there, this is Unit 3, and these notes are on adding and subtracting radicals. We're going to review and simplify radicals, and we're going to learn how to add and subtract radicals. So, to begin, when you're taking a square root, like the whole idea of a square root is trying to find two things. Since this index is a 2, you're trying to find two things that are completely identical, totally and completely identical, and that when you multiply them, they give you this number in here, the radicand. So for instance, if you had the square root of 25, the reason the square root of 25 is 5 is because 5 and 5 are two numbers. These are identical, and that there's two of them, and when you multiply them together you get 25. If you were trying to do the cube root of, say, 27, then that means you'd be looking for 3 of the exact same thing. And so if we go through all our times tables and think about it for a little while, we can come up with the number 3. 3 times 3 is 9. 9 times 3 is 27. So the cube root of 27 is 3. We found 3 things that were identical that give you 27 when you multiply them. For 25, we found 2 things that were identical, and so the square root of 25 is 5. So that's basically the big picture of this. I'm going to show you the process and show you how to add and subtract them as well. There's no decimal answers in this unit. Everything needs to be in what we call simplest radical form. And writing your answers this way is actually the most accurate way to express your radicals. When we have decimals, sometimes we need to round them because they're non-terminating. They go on forever. And so by writing them in simplest radical form, you have the most accurate answer for that particular radical. So with that, let me show you how to do this. So what you're going to do is prime factor. This always works very well with prime numbers. So since we have 243, I'm going to start with my prime factor tree. And I need to think of 2 numbers that multiply to 243. And they can be any 2 numbers that multiply to 243. So I'm going to go with 3 and 81. Since 3 is a prime number, I'm going to circle it because it's going to help me later. 81 is 9 times 9. 9 and 9 are not prime, so I have to keep on doing my factor tree. 9 is 3 times 3. And this is also 3 times 3. So if I'm doing a square root, I'm looking for groups of 2. Since that's a little 2 there, I'm looking for 2 identical numbers that when you multiply them will help me get 243. So I start circling groups of 2 of the same thing. So I have a group of 2 right here, and I have a group of 2 right here. Every time I make a group of 2, one of the numbers come out. So just 1 3 comes out of this group of 2, and 1 3 comes out of that group of 2. Now this leftover 3 right here, that one can't come out because I don't have 2 of them. I only have 1 3, and I need to make groups of 2. So that one gets left underneath the radical. All of this gets multiplied. So this becomes 9 square root of 3. We can't multiply this 3 by the other 3's because it's under the radical. So it's just kind of stuck under there, and that's your answer. Let's go on to the square root of 72. We're doing groups of 2 again. So 72, I'm going to go with 9 times 8. And then neither of those are prime, so I'm going to keep on factoring. This is 3 times 3. This one we'll say is 2 times 4. 4 is not prime, so I keep going. 2 times 2. So I'm going to do groups of 2. So here's a group of 2 of the same thing. Here's another group of 2 of the same thing. 1 2 comes out, 1 3 comes out, and they get multiplied. I got this 2 left over. I don't have 2 of them, so it's got to stay underneath the radical. So your answer is 6 root 2. Let's try a cube root. cube root of 54. So let's see, we're going to do groups of 3 for this one. So I'm going to start with 9 times 6. Neither of those is prime, so I'm going to keep on going. This is 3 times 3. These are prime. 6 is 2 times 3. Those are prime. So now I'm trying to find a group of 3 of the same number, all identical, and right here is a group of 3, right here. So 1 3 can come out of that group. Now there's a 2 left over, so we're going to rewrite the radical and put the 2 under it. Make sure that you put the little cube root in there. That way your answer is the correct number, because the square root of 2 and the cube root of 2 are 2 totally different numbers. So make sure you put your index in there. That's your answer for that one. If I'm going too fast, please feel free to pause the video at any time or rewind it, go back and look at the examples again. Alright, now let's do the next one, 96. So for 96, I need 2 numbers that multiply to 96. How about 2 and 48? 2 is prime, 48 is not prime. So let's do, how about 2 and 24? And then from there, I'm going to do 3 times 8. I'm going off to the side a little bit because I'm running out of space. 3 is prime, 8 is not. 8 is 2 times 4, and 4 is 2 times 2. Okay? So I've got a lot of numbers in there. I'm looking for groups of 4. I only use these prime numbers. So I'm trying to find 4 of the same number. Looks like I've got at least 4 2s here. So here's 3 of them, and then we can like grab this one too. So that makes a group of 4. From that, only 1 2 comes out. Now, underneath the radical, we have a 3 and a 2. So we multiply those under the radical. So this becomes 2 times the 4th root of 2 times 3. So this will be 2 times the 4th root of 6. Now, if you're doing these by yourself, or you're on a test or a quiz and you're nervous that maybe you didn't do it correctly, or you just want to check your answer, remember what this really means. We're just writing this in simplest radical form. We haven't changed the value of the number. So if you do the 4th root of 96 in your calculator, it should be equal to the same number as 2 times the 4th root of 6. This is just simplest radical form. Same number though. So let me show you how to do the 4th root. If you go to math and you go down to choice number 5, you've got a little root there with an X up in the corner. If you hit enter, you can put any root that you want to in there. So I'm going to put a little 4 there, and then I'm going to put my 96 in and hit enter, and I get that decimal. Okay, so a lot of times these come out to be long decimals, so keep that on your screen. Now put your answer in. So this is going to be 2 times, go math and go down to number 5, put the little 4 in there, and then we had a 6 under ours, hit enter, and look, we get the same decimal. So this is a really nice way to check your answers on a test or a quiz. You still need to show all of your work, but if you're really wondering whether or not your answer is correct, you can always check it in the calculator. It should equal the same decimal. Okay, so let's keep going. Let's do the square root of 50x to the 4th. So this is going to be, let's do 2 times 25. 2 is prime, 25 is not. And then we're going to do 5 times 5 for 25. Now this one's got some variables underneath it. So all we have to do with the variables is expand them out. So this would be like x, 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 x. And we're going to do groups of 2 with the numbers. And we're also going to do groups of 2 with the variables. So here's a group of 2 5s. One of them comes out. We have a group of 2 x's. Here's 1x. Another group of x's. There's another one. And then you have a 2 left over. So we multiply this out. It's actually 5x squared root 2. Try some of your practice problems and see if you have any